All right, can everybody see my screen?
Yes, we can.
All right, good. So, thanks for the opportunity to talk about computational storage. And today, I'm going to do, I'm going to talk about NGD systems computational storage. So, NGD systems, NVMe SSD is based on our own SoC. It's a 14 nanometer, 16 channels, enterprise grade SSD, and on every SoC, on top of managing the NAND and being a block storage device that can read, write, and erase, we added an ARM core that is dedicated for compute. And the idea is to take the application or container and move it and process it and execute it at the edge, at the storage where the data reside, and not in the host system. Why would we want to do that? So CPUs and GPUs are very capable in processing data, but when we're looking at very large data sets, the idea of executing or running the application where the data resides provide a tremendous opportunity to increase efficiency of the system. Where you don't have the data going back and forth from the storage to the host for processing, and you can process the data where it resides in the storage, that massive reduction in data movement is translated into a direct increased system performance and reduction in system power. Our abilities are NAND agnostic, so we can use any NAND out there. And computational storage devices, the one that we have, not only reduce the data movement, but allows the user to take advantage of distributed processing. So you have systems with multiple drives, and now every drive has the opportunity to execute the application or the container on the data that reside on that same drive. And now you have a bunch of minions doing your work. And the idea is not to replace the host CPU or GPU, but to augment them, let them do the heavy lifting and do the assortment of the data back where it resides on the storage. So today's demo that I'm going to show you guys is around images. So NGD systems enable the ARM neural network package to run inside the SSD. So the neural network framework, that entire block that you see, is running on each individual drive. Now, each individual drive is holding about 100,000 images that it will show you how the actual drive is managing the images. So we'll start. I have two demos to show you, and they're both related to each other. So we'll start with the first demo. Okay, there it is. So what we have here on the screen, let me see. So this is a server. On this lower left corner is a CPU, the host. Here, what you see is a CPU utilization. And you can see that the CPU utilization went down dramatically once the images are started to being processed at the drive level. Here we have the tab. Each tab represents a drive, and we can see how the system is pulling images from the drive, and we can see a blink of all the different images, and now it kind of stopped. And the reason why it stopped is because we started to add more and more drives, and the actual server is not able to show all the images that are being processed in parallel. So this is the first video that I wanted to share. If we go back now to the second video. Hold on, bear with me while it's loading. Okay, so here we have the same server. The CPU utilization is right here on the left side. And here we we're actually summarizing the entire action that is happening on all the drives in parallel. There's inability of the server to actually show the images because there's too much going on for the server. The server just cannot present the image as we've seen on the previous video. So on the previous video, we took one drive and we start showing you the videos, the images as they popped up. Here is a summary of all the different images that are being opened from all the different drives. And if you can see, it's being listed: drive 1, drive 2, drive 3, drive 4, and it's opening so many drives at the same time that the server cannot even process it and demonstrate the actual images in the display. The NGD systems computational storage engine is multifunction. We can run any application that can be recompiled to ARM and most containers. Our programming model is very simple. We relied on very mature technologies such as TCP/IP and tunneling to enable a direct link from the host system to the drive and enable computational storage. And if there are any questions, I'll be more than happy to answer.
I don't see any questions queued up.
Well, if you see the recording and you still have an answer, don't hesitate to contact NGD Systems and inquire. We'll be happy to support you.
Well, cool. Thank you very much. I'd like to, thank Mayank, Saxena, and Jay Banker and Eli Tompkin for these demonstrations. Thank you very much.
Sure. Thank you.
Okay, so are there any questions we can ask for wrap-up questions from anyone on the call? Otherwise, we'll wrap up a little early. Okay. Well, that wraps up